Welcome back, Pre-Calc. Our objective today is going to be to prove some trig identities. I'm going to force a pause on your screen. You know what to do from here. Alright, I'm going to force another pause on your screen. Can you go ahead and factor these expressions to the best of your ability? And then go ahead and press continue when you're ready to check your answers. Alright, answers are on the screen. You can pause and double check yourself. So the first set is difference of perfect squares. And the second set is trinomial factorization. I just wanted you to see the similarities here basically between this second expression and the first, and then the last two are greatest common factor. All right, I'm going to force another pause on your screen. Please copy what I have, and then we will work the identity together. All right, so this is not that different from what we did 2 lessons ago. We are maybe going to have a little bit more, maybe it's a little heavier on the algebra side, but again, we are trying to verify an identity, so we can only work on one side of the equation. Do you remember what side we typically work on? We typically work with the more complicated side, so I would go with the left-hand side. And the reason we did all that factoring just a moment ago is because we're going to apply those same ideas of factoring to trig expressions. So if you'll notice, I'm going to come back here where we had this x to the 4th minus a to the 4th, and we factored it like so, right? Now instead of x and a, we've got secant and tangent, but we're still going to factor it as basically x squared plus a squared and x squared minus a squared. We've just got secant and tan instead of x and a. So let's try that. We're going to go secant squared of x plus tangent squared of x times secant squared of x minus tan squared of x, right? Difference of perfect squares. And then we are trying to show that that is equal to secant squared x plus tan squared x. All right, so I've got our Pythagorean identities written to the right here. What would you choose to use first, second, or third Pythagorean identity? We are going to use the second. I see secant squareds and tan squareds there. And notice that I want to end with this guy, right? So can we see if we can make this one equal 1? Let's see, let's use this one. So if I subtract over the tan squared, I would get 1 on the left side, and I'd have secant squared x still on the right side, but I'm going to subtract the tan squared x over, right? So I can replace this stuff with 1, right? So that all becomes 1, and I still have secant squared x plus tan squared x. Well, that is indeed equal to what I was trying to prove, right? All right. So we are good there. All right, I'm going to force another pause on your screen. Go ahead and copy this equation, and then we will work it together. All right, so which side would you work with here, left or right? Which one is more complicated? We're going to work with the left. What I'm first going to do is actually rewrite the left side in descending order, so hopefully it's a little bit easier to recognize. So let's do that first. So I'm just going to rewrite in descending order. So I'm going to try to prove that the left side is indeed equal to cosine to the 4th of x. And now let's come back to our factoring and see what this reminds us of. So if you'll look over here, this should kind of look to you like very similar to that, right? But instead of x, I have sine of x, okay? So instead of x squared minus 1 times x squared minus 1, I'm going to have sine squared of x minus 1. So let's go ahead and fill that out. Okay, so I can factor here. Again, as sine squared x minus 1 times itself. So I'll do it twice. Okay, and if you're unsure about that, you can always distribute, FOIL, basically what I just wrote, and you'll see that we do indeed get back to that, okay? All right, so we've got that. We're trying to show this is equal to cosine to the 4th of x. All right, let's take a look at our Pythagorean identities. Which one would you use here, first, second, or third? We're going to use the first, okay? So let's see if we can't get the first to look like sine squared x minus 1. So what I would want to do is subtract 1, right? And subtract cosine squared x. So I'm going to have sine squared x, and I'm going to bring the 1 over, equals, and now I need to bring the cosine squared over, so that would be negative cosine squared x, okay? So now I can replace both of these guys with a negative cosine squared x. And now we're almost there, right? A negative times a negative is going to be a positive, and then cosine squared times itself is indeed going to be cosine to the 4th. And now we have that the two sides are equal, so we are done. All right, I'm going to force another pause on your screen. Go ahead and copy what I have, and then we'll work this one together. All right, so I don't see any squares yet. I don't see a Pythagorean identity kind of blaring at me or anything. So first of all, what side do you want to work on? Let's go ahead and work on the left side. When all else fails, there's a couple things we can do. We can actually just go ahead and work with the algebra. For example, in this case, we can go ahead and distribute. Another thing we can do when all else fails is switch everything to sines and cosines, okay? So I think let's try both of those things. So let's work with the algebra first. Let's go ahead and distribute. So when I distribute the secant of theta, I get secant of theta times cosecant of theta plus secant of theta. And then when I distribute the negative tan, I get negative tan theta cosecant theta minus tan of theta, right? And I'm supposed to show that all of this is somehow equal to cotangent of theta, okay? So far, doesn't look like we've made any progress, right? So again, when all else fails, let's change everything to sines and cosines. So let's go here. Secant is 1 over cosine of theta. Cosecant is 1 over sine of theta plus, again, 1 over cosine theta. All right, minus, now we're to the pink. Tan is sine over cosine. Cosecant is 1 over sine. That's the first good news we've seen, right? Minus, and again, tan is sine over cosine. Okay, so why was that good news? So take a look. I do see a cancellation I can do here. Sine of theta divided by sine of theta, those go away. Okay, so now take a look at what we have left right there. We've got 1 over cosine theta, and now here, all we have left is also 1 over cosine theta. So I have 1 over cosine theta minus 1 over cosine theta. So now those middle terms completely go away as well, right? I had 1 over cosine theta minus itself. All right, so now let's write what we have left. We've got 1 over cosine theta sine theta. I'm going to go ahead and make that one fraction. Minus, and then I've got this piece left as well, sine of theta over cosine of theta. All right, well, when I've got fractions that I'm subtracting, I need to, if I want to combine them, I need to get a common denominator. So in this case, you'll notice my common denominator is cosine of theta times sine of theta. This fraction is missing the what? It's missing the sine of theta. So I'm going to go ahead and input sine of theta in the numerator and denominator. All right, so now I can go ahead and subtract those two fractions since they have the same denominator. Now I can go ahead and subtract the numerators. Okay, and what do you notice about the numerator now? So now the numerator, I can use a Pythagorean identity. 1 minus sine squared theta is the same as cosine squared theta. Double check. your Pythagorean identities. We're getting close now. Do you see any nice cancellation now? So now I can divide numerator and denominator by cosine of theta, so that gets rid of that one, drops that power by 1. So now I have cosine theta over sine of theta. And that is indeed cotangent of theta, right? That's one of our quotient identities. QED, we got it. All right, I'm going to force a pause on your screen. This is our last example, example 4. Go ahead and copy what I have. All right, so for these, which one would you say? Which would you work with, left or right? I'm going to work with left because it's a fraction. And what I'm going to do is I'm actually going to rewrite that. When you've got a fraction, you want to take a look at the portion, either numerator or denominator, that has 2 terms in it, okay? In this case, which has 2 terms, numerator or denominator? Denominator does, and what you're going to do is take the denominator and change the sign between the 2 terms, and what that is called the conjugate, okay? So I'm going to take what I had in the denominator, but I'm going to change that minus to a plus. And then whatever I do to the denominator, I need to do to the numerator as well, right? So I am going to start with that. Just kind of adding some tools to your toolkit here, okay? All right, so let's go ahead and slap some parentheses on here so that it's clear what we're doing. So the point of multiplying by the conjugate in the denominator is that now you're going to get some nice cancellation in the denominator when we distribute. You're not going to have nice cancellation in the numerator, so let's not distribute our numerators. Let's leave them in factored form. Okay, so I'm just going to leave it as cosine of x times the quantity 1 plus sine of x. But now, when you distribute your denominators, you're going to get 1 times 1, right? So that's going to be 1. But now notice I'm going to have sine x minus sine x, and those are going to go away, right? And that's the whole point of multiplying by the conjugate. Then you're also going to have negative sine squared x, okay? And again, I'm trying to get this to be secant of x plus tangent of x. Okay, any light bulbs now? What can I do with the denominator now? I can apply a Pythagorean identity to the denominator, right? What is the denominator equal to? The denominator is equal to, I'll leave the numerator, denominator is equal to cosine squared of x, right? I took that Pythagorean identity and I moved sine squared over. All right. So do you notice anything nice now? Well, now you get some nice cancellation, right? I can divide numerator and denominator by cosine of x. So I'm left with 1 plus sine of x in the numerator and just a single cosine of x in the denominator. All right, now we can kind of do the opposite of combining fractions. Now I can separate that into 2 fractions with the denominator of cosine of x. So I get 1 over cosine of x plus sine of x over cosine of x. Do we see it? Yeah, now we can use our reciprocal and quotient identities, right? 1 over cosine of x is secant of x. And sine of x over cosine of x is tangent of x. And now we have proved what we wanted to prove, okay? All right, so what I'd like for you to bring to class is I want you to list all the strategies we used today, be ready to share, and these are mainly algebraic strategies, okay? So go ahead and write those down and then be ready to share those in class. I'll see you all in class.